Chapter 2 test review, problem number 7. An approximation of the belt length in a motor is L is equal to pi times, notice the two different cases of R in the formula. We have a big R and we have a little r. And that's part of the reason that I get so picky about you guys changing the case of the variables that you use. So it really is important in this particular problem. Anyway, it's pi times that sum plus 2 times d, and d is the distance between these two pulleys. So our job is to find the radius of the larger pulley, and it would make sense that they would use a capital R to represent the larger pulley. And we know that the radius of the smaller one is 7 inches, and the length of the belt is 132, and the diameter, the distance between the two pulleys is 24 inches. So again, let me start with, and we're just going to do this problem one way. We're going to start with the formula that the length is equal to pi times r plus 2d. Okay, so let's see. I'm looking for radius, and I know that the length is 132. I'm going to go ahead and substitute in my values. Pi, I'm looking for big R, plus 7, plus 2 times d, which is 2 times 24. Okay. And I'm after this guy. How about if I go ahead and just solve that real quick? That's nothing. We can do that in our heads just to kind of get a little something out of the way. So that's plus 48. So I'm after R. The first thing that I'm going to have to do is he's got to go. Remember, I'm working from the outside in, and I'm doing the SADMIP stuff. So I'm going to be subtracting 48 from both sides. So let's save a little bit of work here. So I'm going to subtract 48 from this side. And when I subtract 48 from this side, he's gone. That's the whole point. So that's what I'm left with. Well, let's subtract 48 from 132. Well, I can do that. 132 minus 48. 84. 84. Okay. Next thing to go. Pi's got to go. Pi. I'm going to have to divide both sides by pi. And over here, he's gone, leaving me with r plus 7. And I'm just going to let this guy sit there. Next thing to go, the 7. Oh, well, that's pretty easy. I'm going to undo what's being done. The 7 is being added to the r, so the opposite of that is subtraction. So I'm going to be subtracting 7 from both sides. Well, if I subtract 7 from the right side, he's gone, leaving me with r. So on this side, I have 84 over pi minus 7. R equals, I'll put this in my calculator. So I have 84 divided by pi. I'm going to put an equal sign in there just to play it safe, figure out that answer, and now I'm going to subtract the 7 that I have here. Subtract 7. So I get 19.7380. Go back into the problem, and it says, hey, round to the nearest inch, So the radius of my large pulley is going to be 20 inches. 20 inches. Okay, that's pretty quick. Let's do another one on the same video. We'll save some paper, maybe. Okay, reactance offered by a capacitor in electronics is given by this formula. So let me start with the formula. X is equal to 1 over 2 pi times little f times c. F is the frequency measured in cycles per second, and hertz is a shortcut way of saying cycles per second. And C is the capacitor side, and the units for capacitors are farads. And X is the reactance measured in ohms, whatever that is. Find the frequency. So I'm going for F. Find the frequency in a circuit with a capacitor size of that much and a reactance of 13 ohms. And round to 1 decimal place. I'm going to go ahead and substitute the values in. Just my choice. You can do it any way you want. So my reactance, what's my reactance? 13 is equal to 1 over 2 pi f. F is the frequency, and I'm looking for the frequency. I'm looking for that. So I'm going to keep that f in there. And for capacitor size, it's going to be times my capacitor size, which is 0. I like a leading 0, 0, 0, 0, 2, 1. Okay. All right. This is going to be really easy for us to solve. This f is in the denominator, and I don't like them there. So what I'm going to do is I'm going to multiply both sides of this equation by f, and you're going to see that's going to put them right over there on the left. And I'm going to save myself a step. I'm going to multiply this side by baby f, and this side times baby f. Okay, so what do I get out of that? I'm just going to kind of reverse this and say 13f, just because that's the protocol. You usually have numbers before letters. And on this side, make him look like a fraction. You can see that the f's drop out, leaving me with 1 over 2 pi times the stuff 0, 0, 0, 2, 1. Okay. All right, so the f's drop out. Now the only thing I have left to do is clear out that 13. Well, how am I going to do that? I'm going to divide both sides by 13. Now, one of the things that I showed you in class is that when we divide this side by 13, he's going to end up right down here. So I'm not going to go through all the rigmarole of actually pulling that off. He's going to end up down there. If I divide this side by 13, I end up with baby f. And on this side, next up, I'm going to put all this stuff together, times, although I could do it any time I want. And this is going to be times 13. Okay, so I'm ready to tackle this problem in my calculator, and it's going to be very easy. Clear that out. 1 divided by critical parentheses 2 pi, I don't even need a multiplication sign there, times 0.00021. Now, you might say, well, Kathy, how come you didn't enter the 0 in there? I could have, wouldn't have changed anything. 0.00021 times 13. Close the door, and I end up with 58.2985. Go back into the problem. It says round to 1 decimal place. Well, the 2 says leave it alone. So I have 58, or actually, I'm sorry, round to 1 decimal place. Here's my decimal place. I look to the right. The 9 says bump it up. Almost made a mistake there. 0.3. And what are the units? Frequency. Hertz. And I know it doesn't show it, but HZ is a shortcut way of writing hertz. Okay, so that was problem number 8.